later in lecture I'll finish up Mr. Fu's last question, and then I'll start on the topic hypothesis testing.
Joe, do you want to hang up next call?
Okay, so today we'll do sampling distribution.
I think if they ask us like why you want to try, hey, look at me, I feel bad already. I need revision.
So if you turn to the sampling distribution tutorial, okay, anyone who's still doing estimates, okay, refer to the distribution. Okay, this tutorial is mainly based on one theorem. Okay, all based on this theorem. Okay, can you put it down somewhere in your tutorial? Okay, and then with this we can do all the questions. For example, the first one. Sometimes it's given. Then the variance is always sigma squared divided by the sample size. Yeah, the normal thing. Okay, so here the theorem says that x bar has a normal distribution. We are not approximating. We are not saying that this one is this one approximately. It's perfectly a normal distribution. Okay, so no need to do any continuity correction. Okay, straight away use calculator and put in all the commands. If you have forgotten what does the command look like, normal CBF. See, mean and variance. Yes. Yeah, sounds familiar. 0.961. Okay, 3 significant figures. By CLP central theorem. Okay, plus command. Yeah, so means for most of these functions are not done. But after when you see the mean and variance both with the same value. Okay, remember the sigma you have to find square roots of the variance. Okay, then you get a nice answer to the 7%. Okay, in fact these two parts are a bit harder already because you have to calculate the mean and variance yourself. Okay, most of the other questions, the mean and variance are already given in the question. Okay, so I'll put down some some names and then you have to write down the question. They're all very short. Okay, okay, number 2, somebody. Number 3, part 1. Okay, part 3 is the longest one. Nice. Okay, let's have 3 people come and do. Okay, can I have people in the row, second row, third row? I don't remember who asked. Okay, did I? Okay, then let's have people in the first row again. Or the last row, Edward, Christopher. Okay, the last row, Edward, can I do this? Then Christopher, part 1. And the other row of 1. Okay, let's have Fabian. 1, 2, 3.
I can do.
Okay, so like question 1, this is what the working is about, part 1. Here, this X, I don't know what things are they. Okay, my applet here, I draw apples. Okay, let's say there are 30 apples. Okay, apple, then dots. What's the probability that the mean mass of the apples is less than 4.5? Okay, find the probability that the sample mean is less than 4.5. Okay, so straight away I write down the mean and the variance. Okay. The mean is 4, the variance is 2.4 divided by 30. Okay, then I get 0.08. Okay, that's my working over there. And then I just press the calculator to find probability that the x bar is less than 0.5. And then I'll get an answer 0.961. Okay, that's how you do this.
Handle it in
And no matter what distribution we start with, as long as n is big enough, I can give the distribution of x bar. Okay, so let's have okay, everyone look here, stop for a short while. Look here. Okay, let's have a simple distribution. This population only has 2 numbers. Population can say 1 and 3. Okay, now I'm going to take samples. Okay, let's say this population have a huge number. Okay, but it's all 1s and 3s. Okay, now I'm going to take a sample. This sample size 4. Can say sample. So I take a sample. Okay, press F9. Okay, this one by coincidence, my first sample, the numbers are 3, 3, 3, 3. You can see sample size 4. So if I take average, also 3. So what I do, I take a histogram and plot 3, then 1 rectangle. Okay, don't look at the red curve yet, just look at the blue rectangle. And see how I get this first bar in my histogram. Okay, now I'm going to take another sample. Okay, I'll press F9. Okay, now my sample is 3, 1, 1, 1. Sample size 4. Now I find average, I think 3 plus 1 plus 1 plus 1. Okay, 6. 6 divided by 4, I get 1.5. You see sample mean 1.5. Okay, so I can draw another bar in my histogram 1.5. Okay, then what's the the total area adds up to 1. So now it's half and half. Remember the total area under the curve must be 1. Okay, now I'm going to take my third sample. Press F9 again. Okay, now my sample is 1311. Okay, by coincidence it's a repetition. If I find the mean of 1311, I'll get 1.5. Okay, so I plot another, so 1.5 now there is twice the height. 3 is over there. Okay, can you imagine what happens if I do this again and again? Okay, right now only 2 bars, so it doesn't look like any known distribution. Okay, now if I do it again, next sample, again. Okay, if I keep doing many times, what am I getting to? Can you see? If I do many times, you plot the histogram, eventually it should look like a normal distribution. Okay? If it's perfect, it will follow the red curve. Of course, it's very jagged because it's just a histogram. So can you see that originally I didn't start with a normal distribution, but in the end, my sample means they will have a normal distribution. Okay. What is the mean of my new normal distribution? It will be the same as the original mean, 1 and 3. Then my original population is 1 and 3. The weighted average is 2. So I can safely say my new distribution, the mean is also 2. Here the sample size is only 4. So by right also not much. Okay, if I take a bigger sample size, then it looks even nicer. Okay, let's close this. Start again. Okay, now I'm going to do it, but now my sample size is 20. So my population is the same, 1, 3. Now if I take a sample of size 20, you can see
Go back.
the sample is not very long. 3, 1, 1, 1, 1, all the numbers. Okay, so same thing, find every